Good morning, students. In the last period, we have discussed about the defects. Now, today we will discuss about the conductors, insulators, semiconductors. When we are talking about the semiconductors, as you know that the electrical conductivity of the semiconductor material is intermediate between the metal and the insulators. Means, in case of the metals and the insulators, this energy gap, in case of the insulator, this energy gap is very large. Hence, the conduction band remains vacuum. The material is therefore an insulator. The valence band and the conduction band in insulators are separated by the large energy gap called the forbidden zone, and the thermal energy is insufficient to promote the electrons from valence band to the conduction band. We are talking about the insulators. म्हणजे insulators मध्ये हा जो एनर्जी गॅप जो आहे कंडक्शन बँड एक व्हॅलन्स बँड आणि कंडक्शन बँड मध्ये त्याच्यामधला हा एनर्जी गॅप जो आहे तो जास्त असतो. त्याच्यामुळे या व्हॅलन्स बँड मधून या कंडक्शन बँड मध्ये हे एनर्जी इलेक्ट्रॉन प्रमोट करत असतात. जी लागणारी जी एनर्जी आहे इट इज इनसफिशियंट एनर्जी. ड्यू टू दॅट रीजन दिस is such type of the material is called as the insulator. But in case of the metals, there is no gap. There are the free mobile electrons are present into the metals and they can easily move the conductor electricity. But when we are talking about the semiconductors, the electrical conductivity of the semiconductor material is intermediate between the metal and the insulator. The metalloids like silicon, germanium are the semiconductors. Like insulators, the valence band in semiconductor is completely free with electrons and the conduction band is empty. However, the energy gap between the two bands is smaller than that of the insulator. Means when we are talking about this gap, smaller energy gap is between the valence band and the conduction band. And due to that reason, due to this small energy gap, the thermal energy is promoting the valence electrons into the conduction band. At a temperature above the absolute zero, a few electrons in the valence band have enough thermal energy to jump through the small band gap and occupy the higher energy conduction band. The conduction band thus becomes the partially filled and the valence band becomes partially empty. म्हणजे याच्यामधला असणारा हा जो गॅप जो आहे हा कसा आहे कमी गॅप. त्याच्यामुळे या व्हॅलन्स बँड मध्ये असणारे जे इलेक्ट्रॉन्स जे आहेत ते इझिली प्रमोट होऊ शकतात विथ द हेल्प ऑफ द थर्मल एनर्जी. म्हणजे मग त्यावेळेस काय होईल सम इलेक्ट्रॉन्स आर प्रमोटेड इनटू दिस एम्प्टी कंडक्शन बँड ॲट दॅट टाइम द आउट ऑफ दिस एम्प्टी कंडक्शन बँड इट विल बी filled with the few electrons, promoted electrons from the valence band. Means there is the small gap. Partially empty, this valence band becomes the partially empty and this conduction band becomes the partially free. Why? Due to the electrons promoted from the valence band to the conduction band. And the electrons in the conduction band are free to move, and when the electric potential is applied to the semiconductor that conducts a small amount of the electricity. Such poor semiconductor material which has a very low but finite electrical conductivity is called as the intrinsic semiconductor. म्हणजे या ठिकाणी सेमीकंडक्टर किती आहेत हो? दोन प्रकारचे सेमीकंडक्टर, इंट्रिन्सिक सेमीकंडक्टर and extrinsic semiconductor. In the extrinsic semiconductor, a doped semiconductor having the higher conductivity than the pure intrinsic semiconductor is called as the extrinsic semiconductor. The electrical conductivity of a semiconductor increases with the increase in the temperature. This is because the number of electrons with sufficient energy so as to get the promoted to the conduction band increases as the temperature rises. म्हणजे याची कंडक्टिविटी कधी इन्क्रीज होईल? जसं टेम्परेचर वाढत जाईल at that time the conductivity will be increased. And that at the higher temperature there are more mobile electrons in the conduction band and more vacancies in the valence band than at the lower temperature. In fact, the semiconductors are insulators at the low temperature and conductors at the high temperature. Means what I am saying that, listen carefully. Semiconductors are more electrical conductors at the higher temperature. म्हणजे जसं टेम्परेचर वाढत जाईल, थर्मल एनर्जी वाढलेली असेल, at that time there will be a large amount of the mobile electrons. Means हा व्हॅलन्स बँड मधला इलेक्ट्रॉन्स जे आहेत हे या एम्प्टी कंडक्शन बँड मध्ये जातात. at that time there is या ठिकाणी असणारे जे काही इलेक्ट्रॉन्स जे आहेत हे काय होतील? या कंडक्शन बँड मध्ये जातील. ते मोबाईल इलेक्ट्रॉन्स जे आहेत फ्री टू मूव ड्यू टू द एनर्जी. म्हणजे या ठिकाणी काय होईल हो? गॅप पडत जाईल, कमी होतील. हा स्पेस जो आहे व्हॅलन्स बँडचा it will become empty and it will become the partial filled electrons. म्हणजे जसं at the temperature increases the conductivity of the material will be increased. At the temperature means you can say that at high temperature the semiconductors are insulators at the low temperature and conductors at the high temperature वरती हे कंडक्टर्स जे आहेत हे काय असते? हे कंडक्टर्स असतात. परंतु at the low temperature the semiconductor will become the insulator. And in case of the extrinsic semiconductors and the doping, what's mean by the conductivity of the semiconductor can be increased by doping. The process of addition of minute quantity of the impurity at the semiconductor to increase the conductivity is called as doping. means what? म्हणजे एखादा impurity त्याच्यामध्ये एक्स्ट्रा impurity ऍड केल्यानंतर कशासाठी हो? टू गेट द मोर कंडक्टिविटी. that process is called as the म्हणजे other impurity we have to add into that material to get the conductivity, to get the more conductivity. That process is called as the doping. And then another impurity called is the dopant. Doping and dopant. Doping and dopant म्हणजे काय? जो इम्प्युअर मटेरियल आहे, इम्प्युअर पार्ट जो आहे जो की ऍड केला जातो टू गेट द मोर कंडक्टिविटी and the process is called as the doping. And the added impurity is called as the doped semiconductor have the high conductivity than the pure intrinsic semiconductor is an extrinsic semiconductor. म्हणजे हा सेमीकंडक्टर जो आहे तो इंट्रिन्सिक आहे. when you have added the other impurity into that to get the more conductivity at that time that will become extrinsic semiconductor because of the dopant which is used into that process to get the more and such conductor is called as the extrinsic semiconductor. And there are the two types of the extrinsic semiconductors, N-type semiconductor and the P-type semiconductor. N-type semiconductor contains increased number of the electrons in the conduction band. N-type semiconductor मध्ये काय आहे? Increased number of the electrons into the conduction band. हा कोणता बँड आहे? कंडक्शन बँड. दोन्हीकडे पहा, N-type आणि P-type मध्ये. This is the same conduction band. This is the extra electron which is present into the N-type semiconductor, and there is the hole into the P-type semiconductor. This is the valence band where in the both sides. In case of the N-type semiconductor, N-type semiconductor is obtained by adding the group 15 element in the intrinsic semiconductor, which belongs to group 14. For example, we can say that doping of silicon with phosphorus, silicon has a crystal structure in which each silicon atom is linked to a tetrahedral to 4 other silicon atoms. When small quantity of the phosphorus is added to the pure silicon, the phosphorus atoms occupy some vacant site in the lattice in the space of the silicon atom. And the overall crystal structure of silicon remains unchanged. Means here the phosphorus which is added into that, the 4 of the 5 valence electrons of phosphorus atom are unutilized in the bonding to the closest to the 4 silicon atoms. Thus, phosphorus has an extra electron that needed for bonding. Therefore, silicon docked with the phosphorus has more number of electrons in the conduction band than those in the conduction band in the pure silicon. म्हणजे या ठिकाणी पहा, हा सिलिकॉनचा ॲटम आहे, हा फॉस्फरसचा ॲटम. या ह्याच्यामध्ये सिलिकॉन जे आहे हे टेट्राहेड्रल स्ट्रक्चर तयार करतं. त्यावेळेस फॉस्फरस हा जर ॲड केल्यानंतर फॉस्फरसकडे एक एक्स्ट्रा इलेक्ट्रॉन राहतो, मोबाईल इलेक्ट्रॉन राहतो, which is used for the bonding purposes, but it doesn't change the silicon structure by bonding with the other electrons of the silicon. It has one extra electron. म्हणजे या ठिकाणी हा एक्स्ट्रा इलेक्ट्रॉन राहतो इन द p-type semiconductor. म्हणजे it will become the extrinsic p-type semiconductor by doping the phosphorus. phosphorus हा डोपंट म्हणून त्या ठिकाणी यूज केला जातो. त्यावेळेस हा कंडक्शन बँड त्याच्या एक एक्स्ट्रा इलेक्ट्रॉन हे N-type semiconductor मध्ये असलेले आपल्याला आढळून येतात. And because the chain carries the increased number of the electrons, silicon doped with the group 15 elements such as phosphorus, arsenic, bismuth is an N-type semiconductors. While in case of the